Hello guys, it's been a while, but we're finally bringing you an update note for TunaMetaPack 1.3. In this 1.3 patch update note, we've maximized the strengths of our three core tools to enhance both their usability and your overall workflow efficiency. This is going to be a fairly long update note, but I hope you stick with it until the end. The more in-depth understanding you have of each feature, the more you'll be able to adapt and optimize your work pipeline. Great, now let's start the update notes with MeshWarp. The mesh you see on the screen right now is the combined level of detail 0 mesh of the metahuman topology. In this 1.3 patch update, we've added a very special feature to MeshWarp convertMesh tab. The convertMesh function is an automation tool that instantly replaces the body or head mesh with a specific topology chosen by the user. With this update, we've enhanced it to support topology conversion based on 3D scan store meshes. But it's not just a one-way topology conversion. It supports bidirectional topology conversion. This means you can convert metahuman topology into scan store mesh topology, but you can also convert scan store meshes back into metahuman topology. Additionally, whenever you switch between conversion options, the list of available transformation choices will automatically update on the right side of the screen. First, we need to register this mesh as the source mesh. Since we are working with the MH body LOD0 mesh, the metahuman body LOD0 mesh, we'll be converting it into a scan store mesh. Once everything is ready, run the convert button. Yes. As you can see, a new mesh has been generated instantly. If we select the original metahuman mesh, we can see that it has this UV layout. However, when we select the newly created scan store mesh, the UV layout looks different. This new mesh shares the same topology as the Morphable Body mesh available on the scan store site. Let me find it on the site. If we go to the base mesh category, we can see several Morphable Body meshes listed at the top. These meshes all have the same topology as the one we just created. You can see that they are labeled Morphable. Now, let's take a look at their UV layout. Compare the UV layout of the Morphable mesh with the UV layout of our converted mesh. They are identical. However, in the converted mesh, the wire flow around the seam lines appears to be a bit rough. Now, if you adjust the Maintain Offset parameter while selecting this mesh, you'll notice the mesh slightly changes wireframes. By fine-tuning this value in small increments, you can refine the overall wireframe of the character to better suit your needs. And here's something you'll love. DeltaMush is already automatically set up for you. You can also apply additional smoothing if needed. As we covered in previous tutorials, you can separate this mesh by body parts, make copies based on their intended use, and modify them using the Mesh Edit tool. Now, I'm going to blend the body mesh with offset and the face mesh without offset. First, I'll duplicate both meshes separately like this, and temporarily clear the Convert Mesh settings. You can clearly see the difference in eyelid shapes between the two meshes, right? Next, I'll navigate to the Mesh Edit tool tab and register the blend area vertices as a set. Now I'll set the body mesh as the origin mesh. Then I'll select the target mesh for blending, choose the set item I just registered, and increase the smooth value slightly before proceeding. And just like that, we now have a blended mesh with a seamless transition in the desired areas. Everything we did here follows what we learned in previous tutorials. The key takeaway is that now we're not just applying these techniques to metahuman topology, but also to other topologies, making it much easier to create refined, high-quality meshes. Now, let's think about this in reverse. Imagine that you don't have the metahuman combined mesh in the first place. Instead, let's say you purchased a character from the scan store site. Since that character would have the same topology as the scan store mesh, you would need to convert it to metahuman topology to set it up for the metahuman rig. Of course, you could still use Wrap 3D as before, but with convertMesh, you can quickly generate a metahuman combined LOD0 mesh in a much faster and more efficient way. But what happens if we proceed without changing these settings? Let's find out. Oh, a warning message just popped up, telling us that the vertex settings are mismatched. This means that if you try to convert a mesh with a different topology than the current settings, you'll get this error. So, keep this in mind when working with different topologies. Right now, we're using the ScanStore combined body, and we want to convert it into metahuman topology. This time, you should see that a metahuman combined mesh has been successfully generated. You can confirm this by checking the UV layout. It now follows the metahuman UV structure. As I explained earlier, offset adjustments are still available for fine-tuning. If you're satisfied with the conversion and don't need any additional blending, just click the Bake button to finalize it. Now that we've successfully converted this to metahuman topology, you can generate all LODs from it. This was actually introduced in the 1.2 update, so I assume most of you are already familiar with it. Once a non-metahuman mesh is converted to a metahuman combined LOD0, all LODs are automatically generated, and even the additional facial meshes required for metahuman are created automatically. Now, using only the extracted head LOD0 mesh, I will create a ScanStore Morphable head mesh. The ScanStore Morphable head mesh has a different topology compared to the head included in the ScanStore combined body. So, you need to clearly distinguish between the two. First, I registered this mesh here in the convertMesh section and selected the options as shown below. The generated head mesh has a different topology from the metahuman head, and its UV layout is also different from the UV layout of the ScanStore combined body mesh. I'll show you where this mesh belongs on the ScanStore website. It falls under the Metamorphs category in the head section. It is also categorized under Retopologized FACS in the head section. Visit the site and compare the UV layouts yourself. I want to emphasize that this has a completely different UV from the ScanStore Morphable Body mentioned earlier. Since I like this mesh, I'll go ahead and bake it as it is. As I showed earlier, I could also turn this back into a metahuman head LOD0 mesh. Just like this. Now, let me show you some more ways to apply this process. The mesh currently visible on the screen is the ScanStore combined body mesh. I want to separate this mesh into a head and body. Most of you would probably want to cut it based on the UV layout like this. However, for automatic skinning later on, you should never manually cut it like this. Doing so can mess up the vertex IDs, causing issues for auto skinning. To properly split the ScanStore combined mesh into a head and body, you need to use MeshWarp. The MeshWarp template includes a ScanStore topology template as well. While its structure follows legacy metahuman, its topology is designed for the ScanStore combined body. Now, let's go to the Mesh Edit tool tab and use the Split Combined Mesh function again. If you followed the previous MeshWarp tutorials, you'll know how useful this feature is. The tooltip explains that you should first select the origin mesh to be split, then select your combined mesh. Since we're separating the head first, I'll select the head. Next, select the character. Now, you should see a cleanly separated result. Likewise, let's split the body mesh in the same way. Select the template body mesh and then select the combined body of our character, proceeding in the same manner. By doing this, you can also neatly separate the head and body of the ScanStore mesh. This method not only ensures that the seam line remains invisible, but also prevents any future vertex ID issues, so make sure to use this approach. Now, I have loaded the combined mesh that we modified using the ScanStore mesh earlier, along with the head and body that we split, all in a pre-rigged state. Our goal now is to properly apply skin weights to these meshes. In most cases, you would typically open TunaUtils and use the copy skinWeight function, as shown in the previous tutorials. You would select the metahuman mesh as the source, and then select the scan store mesh as the target. However, at least for the scan store mesh, you don't need to do it this way. That's because the auto skin load feature in the metahumanSet tool already contains skinWeight data related to the scan store mesh. To apply the skin from auto skin load, the mesh name must be identical. Make sure to rename your mesh to match the XML file provided here. Now, if you simply press the button, it likely won't proceed. If you check the script editor, you'll see a message stating that you need to select a reference skin mesh in order to apply new skinning. When skinning the metahuman body mesh, the reference skin mesh was automatically recognized, so as long as the name matched, the auto-skinning process worked without any manual selection. However, this is not the case for the scan store mesh. Therefore, you need to manually select the metahuman mesh as the reference skin mesh before proceeding. Now let's check if the skinning has been applied correctly. It looks like it has been successfully applied to the scan store combined body mesh. Next, let's apply to the scan store split body mesh in the same way. First, select the metahuman split body reference, then press the button. Oh, it seems like I forgot to rename it correctly. Let's make sure the mesh names match exactly. Now, after renaming, select the reference skin mesh again and press the button. It should apply properly. Next, we'll do the same for the split head. Start by renaming it correctly. For the split head, you need to select the head LOD0 mesh from the original metahuman head rig as the reference skin mesh. This is crucial for applying the skin properly. Otherwise, you might encounter issues like lips tearing apart or wireframe distortion around the eyes, as I showed in the previous tutorial. Following this method will also prevent any gaps between the body and head from appearing. That concludes the introduction to the convertMesh feature in MeshWarp. This explanation turned out to be quite lengthy, but I appreciate your understanding. Now, let me introduce the update notes for metahumanSet version 1.3. Existing users are probably very familiar with the concept of upVectors. In this update, we've made some improvements to the templates we provide by default. Specifically, we've added upVector locators to joints that didn't have them before, namely the wrists and ankles. Previously, when you used the selected copy-ref attach mesh feature and clicked the body joint to ref joint matched button, the program would automatically align the joints to a certain extent, right? In earlier tutorials, I mentioned that for wrists and ankles, you needed to adjust them manually first. So, many of you likely located the hand joints at this step, unchecked the option, and roughly aligned their angles and positions. This step is still necessary to ensure precise positioning, but now you no longer need to align the rotation perfectly. That's because, like other joints, the wrists now have upVectors. You only need to align the position of the upVector accurately. After that, simply press the All Joints Axis Align setting button, and the rotation will be corrected automatically, just like with other joints. Once you've finished adjusting one side, you can easily mirror the adjustments to the other side using the upVector mirror feature from a previous update. For the ankles, the process is similar, but there's one special detail. There's a checkbox that allows you to skip the joint rotation axis alignment for this area. Since the Z-axis of the ankle may need to be perfectly aligned with the ground, relying solely on the direction of the upVector for rotation might not always align the Z-axis properly. To address this, we've added a default option to exclude the ankles when using the All Joints Axis Align feature. Of course, the X-axis direction can still be easily aligned using the upVector. So, uncheck the Skip Ankles checkbox, adjust the direction using the upVector, then recheck the box to manually align the Z-axis to the ground. Let's take a look at the newly added features in the metahumanSet tool. A new tab has been added, Body Angle Set. This feature allows you to save and load the body joint angle values of your character. Even if your character's current rotation value is set to 0, it still has its own unique absolute orient values. Let's save those orient values separately. When you click this Save button, a file dialog will appear, allowing you to save the current body angle information of your character. By default, the folder that opens first is the angle folder within the metahumanSet template folder. Make sure to save the file in this location. Once you save the file, the saved item will appear in the list. Now that we've saved the body angle information of the metahuman template, let's try loading a completely new character. For convenience, I'll load one of our cartoon characters. As you can see, this cartoon character has completely different arm and leg angles compared to the metahuman template we used earlier. From here, I'll select the previously saved item from the list and press the Apply Body Angle button. A warning message pops up, stating that all joint angles of the current character's body will be forcibly adjusted based on the saved information. Let's proceed. It seems to have been applied, but something feels off, doesn't it? While the angles for the arms, legs, torso, and fingers have all been applied correctly, something feels unnatural. Let's undo the changes by pressing Ctrl-Z and try again. Do you see this part, the clavicle? It seems to have been adjusted significantly. Depending on the shape of the character or the preference of the person setting it up, the clavicle may sometimes be positioned higher or lower. This happens because there isn't a clear absolute standard for it. If the character's clavicle was initially set higher, it may now look as though it's been pushed down too far in the situation. However, if you simply raise the clavicle back to its original position, the angles of the arms will change again, right? So, what should we do in this case? If you check the tooltip for the Select Main Driver Joints button, it says that it selects the main joints. And if any joints are already selected, it allows you to apply the body angle only to those specific joints. In other words, you can press this button to select the main body joints, and then exclude the clavicle joint from the selection. For those of you who are new to Maya, here's a quick tip if you want to exclude something from a selection. Hold Ctrl key and click on the object you want to exclude. Once you've excluded the clavicle joint and all the main joints are selected, let's apply the body angle again. All right, this time, the results look much better. Now let's temporarily load the original metahuman template for comparison. As you can see, even the finger angles are very similar. Using this method, you can forcefully adjust the joints of any character to be exactly the same. However, since the clavicle can have noticeable differences, it's a good idea to establish a consistent standard for the clavicle angle when you initially set up your character. The reverse situation works the same way. This time, let's save the body angle of the cartoon character and apply it to the legacy metahuman template. When you apply the body angle to the whole character as is, you can see that the clavicle gap is again quite significant, right? Just like before, let's exclude the clavicle from the selection and try again. The results are better, but now the spine looks a bit off. Let's exclude all the spine joints and try again. Now it's leaning forward slightly. In this case, I'll include only spine 1 in the selection. There we go. Now the shape remains intact, and we've achieved a satisfactory angle. If you want to apply the angle only to the fingers, you can select the entire hierarchy of the wrist and apply it. However, in doing so, the wrist might get twisted, so you'll need to restore it to its original form afterward. Let's compare the body angle with the original cartoon character from the earlier state. When you do this yourself, don't load two templates into a single scene like I just did. I'm only loading both templates into the same scene to test and check the angles. Looking at the angles, they seem to be quite similar. And that concludes the introduction to the new features added to the metahumanSet. In this first point 3 update to the DNA editor, 2 features for detailed editing have been added. To be honest, the first feature has existed before, but it was highly unstable, so we intentionally didn't disclose its existence. This time, after conducting some thorough testing, we're introducing it. While not many of you may need this feature, those who want to make precise modifications to DNA logic might find it worth trying. First, either attach the character's namespace or load a DNA file into the DNA editor when only the facial rig is present. If you navigate to the Behavior tab, you'll notice a button labeled Add PSD or Edit Logic. This feature allows you to either modify existing PSD logic or add new logic. For now, I'll start by setting the output path for the DNA file. Next, I'll click this button. At this point, you'll see a warning prompting you to select a target mesh. The target mesh here refers to the mesh associated with the logic you want to edit or add. Then a dialog window will appear as shown above. In this window, you'll see 2 options: Add PSD logic and Edit logic. Let me now clearly explain when and how to use each of these options. Let's assume your character is making a facial expression that combines brow down and eye blink simultaneously. Normally, most people would edit each expression separately. However, those familiar with PSD logic may want to check if this exact combination already exists and modify it directly. This is where the issue arises. While it would be ideal if the desired logic already existed, that's not always the case. For example, in the case of brow down plus eye blink, there is no existing PSD logic for this combination. There are other similar logics, but none specifically for brow down and eye blink together. This means that if this PSD logic does not exist, you won't be able to adjust the blend shape for this combined expression directly. Instead, you'd have to modify each expression's logic separately. Now, let's make that expression again. Since it doesn't exist in the PSD list, we'll create a new logic entry. If Add PSD logic is selected, you'll see a new logic number appear at the top. The last logic index in this DNA file is 733, so it makes sense to create the 734th logic entry. And if you look inside the Compose Logic section, you'll notice that the currently modified logics have been automatically registered. It's important to ensure that each composed logic has its value set to the maximum. You can also set the blend shape name here, which is automatically suggested. Since the auto-suggested name follows the correct format, it's recommended to leave it as is. The source object name here refers to the source that will be used for the blend shape data. For example, if the source is head LOD0 mesh, it means you'll be using its current shape directly. With the newly created logic, you can add both blend shapes and a joint list. When you select the desired joints and add them here, all joints within the group of the selected joint will be included in the logic. For the blend shape, you can simply duplicate the head mesh, make the necessary modifications, and register it here. Once everything is set, you can now execute the operation. When you do, a message window will appear. The message will say that the DNA file will be saved to the output path you specified earlier and then reloaded. In the Details section, you'll see the index number of the composed logic. Let's go ahead and save the file. When prompted whether to save the current DNA, it's a good idea to save it once more, just in case. Now, if you check the very bottom of the logic list, you'll see that the newly added 734th logic has been successfully created. Now, your new PSD logic has been successfully created in the DNA file. The applied blend shape is working correctly, and the registered joints have been properly included. The blend shape name is exactly as you set it earlier, and the actual blend shape has been properly registered as well. For those using the Add PSD or Edit Logic feature, it's highly recommended to back up your original DNA file beforehand. There could be unforeseen issues during the process. Now, let's move on to the steps for modifying the new logic we just created. Click the Edit Logic button, and a logic selection window will appear. Select the logic you want to edit in this case, the one we just created. Once selected, the expression logic that makes up this logic will be automatically registered. We'll also change the blend shape name here. Oh, I forgot to refresh. When you select the Edit Logic option, it will automatically refresh. You'll notice that the title changes to Edit Logic Number. If you click Add PSD Logic, it refreshes the interface as well. Similarly, clicking Edit Logic will refresh everything. One key point to note is that the selected logic in the logic selection window determines the logic being edited. If you select a different logic and refresh, it will update to display the newly selected logic. The option box acts as the refresh, so be sure to hit refresh before proceeding. For now, I'll add another expression to the 734th logic we just created. Specifically, I'll modify logic 734 to include 3 expressions: brow down, eye blink, and brow lateral. In the logic selection window, select brow lateral and click the plus button to add it to the compose logic list. This time, I'll create a random blend shape name as an example. I'll also keep the blend shape mesh as the current head mesh. Now, let's apply these changes and see how it works. Likewise, the tool will automatically save the modified DNA file to the output path and reload it. If you check the details, you'll now see 3 logic indexes listed instead of 1. Great! Let's proceed. Once the save is completed successfully, go ahead and check the updated PSD logic. Can you see that it now consists of 3 expressions? Also, the blend shape name has changed to ABCD. Now, if I remove even one of the 3 expressions, you'll immediately notice that the PSD logic won't activate anymore. For example, using only brow down and eye blink won't trigger the blend shape values. The brow lateral I added earlier must also be included for the blend shape to work. This means that if any one of the 3 expressions is missing, the blend shape won't activate. This is how PSD logic functions, and it's essential to understand this concept clearly before using it. Now that I've successfully added a new blend shape, I'm going to export the head rig again. First, I'll remove the namespace. By now, I'm sure all of you are familiar with how to export the head rig. Let's switch back to the engine. I'll replace my character's head skeletal mesh with the newly exported one. I'll also replace the DNA file with the one we saved in the output path. Next, let's open the skeletal mesh and check the Morph Target section. You should now see that the ABCD blend shape we registered earlier is successfully listed just like this. Now, if we check the animation using the facial control board, we can confirm that the blend shape functions exactly as it did in Maya, and that the PSD logic is working properly. If anyone finds that this doesn't work, try the following troubleshooting steps. Re-import the skeletal mesh, then locate the face archetype skeleton. Open the skeleton settings and check whether your newly created blend-shape curve data is listed. If the curve data is missing, re-import the skeletal mesh as an FBX and verify that the morph checkbox for the corresponding blend-shape type is enabled. In general, it's best not to modify the face archetype skeleton, but in special cases like this, where a new blend shape has been added via a new PSD logic, you must re-import the FBX and make sure the new data is properly stored in the skeleton. Even if PSD logic itself is functioning correctly, the blend shape might not be recognized due to missing curve data in the skeleton. Lastly, I strongly recommend back up your DNA file before modifying PSD logic. Instead of overwriting the DNA, make a copy first to avoid potential issues. Alright, this time, I'll share the new features added to the DNA editor in version 1.3. First, I'll add a namespace and briefly open the DNA editor. Here you can see that a new tab called Animated Map has been added. In the metahuman system, a total of 82 animated maps are used. Each of these 82 items represents a predefined logic for the animated map. Now, let me open the hypershade and navigate to the Texture tab. Here, you can see over 30 different mask maps, all of which are used for animated maps. The base map file head color I selected here is the file texture that defines this character's base head color. I'll go ahead and delete this for a moment. Since the base color path is now missing, the texture automatically turns black. Now, if I select any animated map logic and click on the corresponding rig logic item, you'll see the movement being applied and a wrinkle map appearing. In simple terms, a single animated map logic is composed of multiple rig logic setups and reacts accordingly. This means that the rig logic matching the name of the animated map corresponds to a specific mask region. In the Texture tab, the texture maps that make up the animated map include head, CM1 color, CM2 color, CM3 color, WM1 color, WM2 color, WM3 color. In other words, the 6 texture map combining diffuse and normal maps represent the entire animated map region. The value parameters shown here define how the rig logic behaves under specific conditions. You can add additional rig logic to an animated map logic, remove unnecessary rig logic from an animated map logic. The slope value represents the weight applied when movement occurs. If this value is 0 or less, the corresponding rig logic will not be applied. For example, if I change the slope value to -1.0, it means that the 0th animated map logic will not be activated when the brow down movement occurs. A clear example is this. It already has a slope value of -1, meaning that when rig logic 262 is triggered, the 0th animated map logic does not activate. This is exactly the area I'm pointing at with the mouse. On the other hand, rig logic 20 has a slope value of 1.0, so it functions properly. Now, let's look at rig logic 319. Here, we see a FromValue parameter. The FromValue defines the minimum threshold required for activation. In this case, it's set to 0.25. Let me show you an example. If I set the controller to 0.25, the 0th animated map logic does not activate at all. If I increase the value beyond 0.25, you'll notice it starts activating slightly. The reason it moves very subtly is because the slope value is only 0.266. There's also something called cut value. The cut value forcibly limits the slope value. Here, the cut value is negative, 0.666. So the final value of this animated map logic is determined by slope value plus cut value equals 0.2 when the rig logic reaches its maximum. Let's open the shader to confirm this. Here, you can see channel 00 multiplier, which refers to the 0th animated map. You'll notice that the value is set to 0.2, just as expected. channel 0, 1 multiplier does not refer to the right side. Instead, it represents the normal map rather than the color map. Since color and normal maps have separate logics but follow the same principles, they are processed simultaneously with the same values. Now, as a test, I'm going to change the slope value of the brow down logic in animated map logic 0 to -1. Then I'll press Edit Apply. Oh, I made a mistake. I forgot to specify the output path. After pressing Edit Apply, a message pops up asking if I want to save this to DNA. For now, I won't save it, because I've only modified the color map logic, but I haven't adjusted the normal map logic yet. Let's modify the normal map logic to match. The message pops up again, and this time, I'll save it to DNA. Now, you'll see that when moving the left brow down, no wrinkle map appears anymore, but the right side still works correctly. Always ensure that the normal map logic matches the color map logic. In Maya, it may seem like only adjusting the color map logic works fine, but in the engine, both must be modified for them to function properly together. Now, let's apply the same logic to brow lateral. As I mentioned earlier, I must also modify the normal map logic to match. Of course, if you want different levels of effect between the color map and normal map, you can manually tweak them as needed. Understanding this concept and workflow might feel a bit confusing at first, but once you get used to it, you'll have full control over MetaHuman's animated maps. Let's continue with left blink without saving just yet. After modifying each logic, you must press Edit Apply before moving on. If you skip to another logic without applying, the changes won't take effect. Now, after applying, you should clearly see the difference between left and right. Let's try this with mouthSmile next. I'll only modify the rig logic for lifting the corner of the mouth, leaving everything else untouched. Here, the from value is 0.25. As I mentioned earlier, this means values start applying only when the control reaches 0.25 or higher. The slope value is 1.333. This means the wrinkles appear 1.3 times faster than normal, more exaggerated effect. The cut value is negative 0.333. So, when added to the slope value, the maximum effect reaches 1.0. Let's check in the shader. As expected, the value is 1.0, confirming our calculations. Now, does this principle make sense to you? Finally, I'll set the slope value to -1 as before, and I'll reset all other values to 0. Of course, must do the same for the normal map logic as well. Do you have a general idea of how to make modifications now? As I briefly mentioned earlier, aside from simply adjusting numerical values, you can also add or remove rig logic as needed to create more diverse modifications. Now, let's check if the changes I just made are working in the engine. Updating the animated map logic in the engine is very simple. Since we are not modifying blend shapes like in PSD edit logic, there's no need to re-export an FBX and update the skeletal mesh. You only need to replace the DNA file with the newly modified one. Oh, wait a moment. Let me slightly increase the brightness of the left light so we can see the wrinkles on both sides more clearly. Now, this expression is identical to the one in Maya. Let's switch to the newly modified DNA file. Please focus on the left side of the character's face. I'll save the skeletal mesh briefly. Oh, it has been applied. What do you think? You can clearly see the difference in how the wrinkles appear on the left and right sides, right? This way, you can modify the animated map according to your needs. However, to make proper adjustments, you need a solid understanding of rig logic. With that, we conclude the update notes for version 1.3. The focus of this update is detail. While many users may not require such fine-tuned modifications, for those working at a truly professional level, every single detailed adjustment feature can be invaluable. We will continue to do our best to support you until our tool becomes a truly indispensable resource for everyone. Thank you for watching this long video.